Greetings and welcome to the Industrial Lens Podcast. Here we examine cutting-edge insider knowledge on industrial equipment, strategy, and trends so that you can thrive and stay ahead of any challenges, seen or unseen. Now, let's get industrial.
Good morning and welcome to the Industrial Lens. My name is Eric Hassen. I'm sitting here with Joseph Lyden. Good morning, Joseph.
Good morning, Eric.
So, do you have any ideas on what we should talk about today?
I do. We wanted to straight talk about push-pull.
Well, I think for everyone listening out there, we should probably define what push-pull is, what space we're talking about. So if you want to get that rolling, I'll let you get fired up.
Yeah. So in the world of casters and wheels, safety and ergonomics is, one of the highest priorities, one of the most discussed topics. And, with that comes push-pull forces. And what that means to people that aren't familiar with measuring push-pull or why that's important, push-pull is basically just taking a measure of the force required to start a cart, to get a cart moving. And you take a force gauge of some fashion, and they vary in complexity and simplicity and cost, digital, analog. But you attach a device to a cart, and you measure how much force is required to get it moving. From a couple of different ways with the casters in the straight direction, casters at 90 degrees, basically the most difficult starting position. And then you're taking a series of measurements and trying to determine, how much push force is required to get the cart moving. And then you could take subsequent tests to measure how much force is required to keep the cart moving. And taking those measurements are important because they can determine, how much weight you could put on a cart, how much load you could put on a cart, how often an associate on the floor could move the cart. And different corporations have different thresholds for what they deem acceptable, but really it just comes to mitigating risk and reducing the chance of injury of the team member on the floor that's pushing and pulling the cart all day. And one of the things that always tends to come up is that there's a lot of human element to pushing and pulling a cart, especially when you're doing a test. Because when you attach a force gauge to a cart, the speed at which you push the cart can really determine the reading you get on it. If you start with a very forceful, almost jerking motion, you'll get a much higher reading. If you go into it gently and you get the cart moving, get a much lower reading. So there's a lot of ways that you could, I guess manipulate's a bad word, but there's a lot of different ways that you can influence the results of the test, and a lot of that is human element. Some other things that come into play is that from a caster perspective, you're testing the casters kind of in a vacuum. These are brand new casters, pick of the litter casters, and they're being tested in a clean, flat environment, which isn't really always going to be the case. You fast forward a year, and the casters look much different. They've possibly picked up some debris. They've possibly been worn down. The bearings, the swivel raceways, things like that have possibly have some dust and dirt in them. The flooring might not be as flat and smooth and as the testing was done. So, it brings in a lot of questions in regards to, how accurate and meaningful the initial push-pull testing is to the real world, and, how much potential injury are you reducing. Which brings us to one of the first points in kind of understanding push-pull a little bit further is looking at there's some standards. There's an ISO standard, which Eric is going to kind of walk us through a little bit for us. But I just wanted to kind of give you an overview of what, just from a high level, what push-pull testing and looks like. So now Eric's going to talk about the ISO standard.
Now, that was a great overall description. When it comes to the push-pull, and depending on what facility you're in, Joe mentioned everyone does have a different standard. And to help, assist with that, there is, whether you know it or not, an ISO standard when it comes to push-pull forces, and that is the ISO 11228-2 push-pull standard. And just to paraphrase this, because it would be illegal for us to read it verbatim, you do a couple different sets of tests. So you need to put the swivel casters perpendicular to each other, whopper-jawed, if you will, because when the casters are whopper-jawed, that creates the highest initial starting force. So you do 10 trials, provide the average of those trials, and then you put the casters in the trailing position, what we would call 0 degrees, and then you do 10 trials and do the average of those. As Joe mentioned before, there's a tremendous amount of subjectivity, and specifically when it comes to the velocity of how quickly you push or how slow you push. So there's a definitive time over distance in the ISO standard that you need to adhere to. And with the continued push-pull testing that's been done over the years and the use of the current ISO standard, there did need to be an assessment and an update to that. So there's a new addendum out there that helps adjust the velocity and the time over the distance to help provide that a better risk assessment to your folks on the floor. Because everyone out there is struggling with labor, and from a caster standpoint, if we can help assist reduce that push-pull force to reduce the risk of someone getting hurt, because we don't want anyone getting hurt out there. You could lose a very tenured employee that's very valuable to your organization when possibly it could have been avoided. So, with the labor struggles out there, push-pull and the whole safety aspect is a huge thing that at least we see out there in the world when we're visiting facilities helping with this sort of stuff. Sure. Just so everyone knows that there is a standard out there, but there is such a tremendous subjectivity to it. And then corporate standards could be as low as 15 kilograms, upwards of 15 pounds of push-pull force, depending on what you make. So, even though there is an ISO standard out there, there's still a lot of variety to,
For sure.
The push-pull standards out there, which is fascinating.
Yeah, and and having standards is important because you want to be able to, replicate a test, or talk the same language in regards to, what push-pull reading you did, achieve, or what came out of the testing. But when you're talking about like just the real world and how we work to reduce risk, the testing is one piece of it, but really, putting, when we're talking about casters and wheels, that's obviously what our organization does. But from a caster perspective, putting the casters in play in the environment that they're going to be used and getting feedback from the people that are going to push them around all day, to me, is much more critical than what whatever numbers come out on an isolated test done in a vacuum with brand new casters, with a device hooked up to it. And that's why, when we're going into a facility, we really want to understand what the application is and how push-pull is going to affect that application. What is how often throughout the day is this cart being pushed around? Is the cart being towed? A lot of these things come into play. And I'm not trying to, downplay the testing, but in our years of, experience and from what we've seen, the push-pull testing that we do in our facility might not always line up with what the numbers that come back from a corporate ergonomist. And, I think that it's really just kind of somewhere in between those two is what the where you can get the best results. And I think the most important thing, at the end of the day, what everybody's goal is to protect the employees and reduce risk and reduce injury. And, that's not always done with a test. But, you got to start from somewhere, and there is a lot of validity to the testing that is done. But from my perspective, I think that it's as important to get feedback from the people that are going to be pushing around the carts. And there's a lot you can learn too from just the orientation of the casters. You know, like Eric was saying, the testing is done at 90 degrees, which is the worst starting position. But if you educate the guys that are going to be pushing around the carts to just take an evaluation as they walk up to the cart to look at the orientation of the casters, you can reduce the push-pull force just by, you know, educating them on, like, we're going to start the cart in this direction. And that would kind of eliminate that 90-degree starting position. And just little stuff like that, I think is somewhat overlooked as opposed to just trying to figure out, you know, how in a vacuum that we can get the lowest possible reading.
Yeah, we call it the Pepsi challenge. So like if we go into a facility, we prefer to get actual empirical data with the end user. So we use the casters that are on the cart that are causing the issue, and then, you know, when it comes to getting the proper information in regards to recommending casters, we bring in a set of sample those and just do side by side push pull testing just to see, you know, what the difference is. And, you know, Joe, when you're looking at the multitude of variables, you know, what is the biggest driver of push pull force?
I mean, it really comes down to the lead on the caster is a huge one. Obviously, its weight, you know, is gonna be the biggest challenge. But the easiest variable that you can change is the offset or the lead of the caster. You know, from our experience, that's been more important than even, you know, the wheel. There's all of the variables are important, but and I think that's where you were going.
Yeah. Well, if you don't know what a caster is out there,
Yeah,
and you say
right.
changing the lead, can you just try
Sure.
and create a visual for
Yeah.
those lovely folks out there?
Yeah, the lead of the caster is the distance measured from the center of the axle to the center of the swivel section. And, you know, we don't have a visual to give you, but basically that distance is what's called the swivel lead. And as you extend that, if you can extend that out, increase the length of the swivel lead, you drastically reduce the push-pull forces, especially when you're talking about starting from 90 degrees to get it in the natural trailing position. So that's what we mean by the swivel lead. So extending that just drastically reduces, you know, even moving it, you know, half inch, makes a huge difference.
And you're talking in regards to a caster configuration of 2 swivel and 2 rigid. What if I need 4 swivel or 360 rotating casters on my cart? What does that do to ergo?
Well, first I would try and talk you out of that
Quickly. Very quickly.
4 swivel casters is not fun for anyone.
If anyone's ever been to
but
IKEA,
Yeah, I've been to IKEA and tried to push that cart around in a reasonable way.
winding path.
Yeah, it has a mind of its own. It's 4 casters fighting themselves. So you run into a whole lot of different. You can't even really replicate a test from a push-pull standpoint with 4 swivels. So I mean, if you need a cart to rotate, you know, more freely, or if you need to get an entire space, you know, going to a 6-wheel configuration with a center rigid caster and 4 swivel casters on the outsides, on the corners, is a better solution to that. So 4 swivels is no bueno for anyone.
So what the total load is a very important component. So how do I figure out what load rating, what caster I need when I know what the total load of my cart is? How do I figure that out?
Well, I mean, you have the total load, so you have the weight of the cart, and then the weight of the the payload, or what you want to put on the cart, and then you're going to want to figure out what's important. If you're towing it and it's not hand pushed, your rule of thumb is you're going to want to divide by 3 because you don't want to go with the full capacity of 4 casters, because you might have a floor that's not 100%. True. So you might have the load being dispersed over 3 casters as opposed to 4. So that's a good starting point. And then you want to determine, what is your threshold of push-pull forces. And then you need to determine, if this is truly just a hand push application, can you get away with using a harder wheel, that's on a smooth surface. So it really, there's a, it really just depends on the application and, what is most important to the end user. Is it durability? Is it noise reduction? Is it push-pull forces, floor protection? All of these things are, are conversations that are had when you're reviewing an application. And it's really just up to the end user to decide, what's most important to them. And, of course, everybody wants to move a lot of weight and for the caster to last forever, but in the real world, you need to make decisions on, priorities about what's important, and then you work backwards from there, and then trying to come up with the best solution so that once the casters are implemented, they're not talked about anymore. Because I think what we've said before is that casters are only talked about when there's a problem, and that's true. If you go in a facility and everything's just rolling around and product is flowing, nobody cares. You're not going to celebrate the casters. That's cool. But if there is a problem, there's a lot of there's a spotlight on them, and then that's when we like to come in and try and make a recommendation to get them going in the right spot.
And you brought up a good point to get back to the ergo piece, and just for general basic knowledge for everyone out there who does use casters or will possibly use them in the future. Some good general rules of thumb just to make everyone on this listening to this dangerous. The bigger the wheel, easier to push. The harder the wheel, easier to push. Now, if you decide to use a hard wheel because you'll lower the ergo versus a softer tread, polyurethane or rubber, between 15-25%. Hard wheels do bring caveats. So like as Joe mentioned, when you're deciding which caster to choose for your specific application, harder wheels do bring in, debris retention. They could possibly damage the floor. They can increase the noise level in your facility. And they're great when they're brand new, but over time, as they deform, your ergo will go up, and they do have high replacement costs. But if you're pushing around something really heavy and only hand pushing it, because we don't recommend tugging hard wheels due to the sliding and safety issue it can cause in your plant, or if you're in a washdown, you need a very specific wheel, possibly a hard wheel. They can work out very well and solve ergo problems, but just be aware there are caveats that come with using those types of wheels.
Yeah, and just to kind of expand upon what the hard wheel in a towing application, just think of that if you have a hard, smooth wheel on a hard, smooth surface, especially if you're towing a train of dollies or carts, and you go around a corner, that's going to, kind of whip and slide. So you want to have, in a tow line application, you want to have, a wheel that's going to provide some grip, some resistance from sliding, or else it could cause a lot more problems in the long run and potential injury or damage to product. And so that's what Eric's talking about when we talk about like a hard wheel sliding, and you need that grip. So trying to come up with, and that's what when you look at an application, you got to look at everything, and you got to look at how the whole path of the cart, and how it's going to be used throughout the day, not just at one piece, in time, or one snapshot in time. You need to look at the whole collective use and application of the cart, and that's why you need to make decisions. You need to determine what's important to you, and you might have overall height restrictions, or you might have to be tying into an existing dimension design because it needs to make sure that it matches up. So all of these things come into play. But circling back, why we're talking about the push-pull, testing, which, like I said at the beginning, I don't want to minimize. It's important, and it definitely kind of eliminates some, products or casters that you might or might not be able to use. But I guess the overall message is that it's not the end all be all, and considering the guys that are going to be pushing it, guys and gals that are going to be pushing it around, that's the most important piece of it if you're really talking about protecting them and reducing injury. And that's why putting product in to try is a prudent play, because you're gonna get a better sense using it in your application, in your world, with getting real feedback from the people that it's going to affect.
And just so everyone out there knows, I mean, a push-pull injury, it's the number one injury. The lower back strain is the number one workman's comp claim out there, and it can average, I think with the most recent data over the past couple of years, could be upwards, the average is $81,000, if not more. And just looking at, what casters cost and choosing the right ones versus not choosing the right ones, that could cause a big issue within your facility if you're losing important staff members and then also having to pay high insurance claims and things of that nature. There's another, caveat to consider when choosing the right caster, cost versus the right one. You could choose the wrong caster up front and replace it once a month, or pay a little bit more for the correct caster, but then you don't replace it for 3 years.
Right.
So
It's the price versus cost type of a thing. Yeah. I mean, when you got to look at the total cost of ownership, which is, sometimes difficult when you're looking at budgets and it's not always tangible. The other associated costs with, using the wrong or right caster. But it is critical, and it's just, we're just trying to give you some things to think about when you're talking about, this specifically push-pull and casters and wheels.
And I think that there is benefit, to have someone come on site to the facility, because if you work in that plant, just like when I work in the office, I see the same thing over and over and over again, and you become just conditioned to it. So to have a fresh set of eyes looking for very specific things can be a benefit, especially when, we're talking about casters and applications and not knowing all of the information. Virtual meetings are great, but, sometimes it does benefit to be on site and be in that facility and see what's really going on out there.
Yeah, looking and understanding the application and talking it through with the people that live in that world, and then bringing, expertise and just maybe even just some, probing questions that might lead to, think about it from a different way. Is from our experience is what's worked the best, and where, then everybody can get into the place where they want to be, which is, successful applications and, not worrying about things or downtime or, replacement costs or, injury, which is the one that we definitely want to avoid. So I agree 100%.
Yeah, numero uno.
Yeah. So, we covered a lot of stuff there in regards to push-pull force, but to kind of just summarize, as Eric mentioned earlier in the podcast, that there are standards out there for testing, and that is important so that people are following similar guidelines and that they can be, speaking the same language. But, we just encourage, you to think about it more than just the test, and really understand that the human element of it is massive, and that needs to be considered for certain. So when you're doing push-pull testing, do the standard testing. You need to have a baseline, but take the extra additional step. Talk to the guys that are going to be using these carts. Understand maybe what issues they've had in the past. Address those, and then try and end up with the best caster in the long run, not just in the vacuum for the initial testing. That's the advice that we could give. And, another avenue that we have experience with is that we did a project with the Ohio State Spine Research Institute, where they looked at kind of similarly. They did some testing where they wanted to be more real world, and they looked at it from a perspective of they had a cart, and then they had some lab rats. That's wrong. What would you say? Like test folks? Just some
Subjects.
test subjects. There you go. And they said, "There's a cart. Go push it." Without any instruction about how fast, how far, in what direction. And then they did the same test with providing instruction. And then they did the same test with providing different instruction. And it was pretty wild how, how much the data kind of lined up. The standard testing did line up kind of similarly with what without any instruction about how to push the cart. I guess is what I'm saying. Is that
I think as you're trying to say, if you said just go push it,
go push it?
the values were much higher
Yes.
versus according to the old ISO standard,
Right.
which the Spine Research Institute, I think, really helps support the addendum and the importance of velocity and that training aspect
Yep.
that you mentioned of the staff on the floor, because everything really aligned, with the data that the OSU came up with, and when you look at it from the addendum standpoint, it really helps support that and the importance of how fast are you pushing and what those numbers really mean and how important it is to do it on site with your cart in your conditions versus the most state of the art lab in the globe
Right,
when
sure.
it comes to push pull testing.
Yeah, I mean, and that's where that spike could come in. If you come in and just push it really hard, you're going to get a much higher reading, and that could lead to injury. Yeah, so that was interesting, and there'll be we have links on our website to all of that, all of those studies and further write-ups from the Spine Research Institute at The Ohio State University. So we encourage you to take a gander at that information.
Yeah, there's a tremendous amount of just general educational information. www.casterconnection.com. Go to the Caster Education section, and you can find all kinds of ergonomic push-pull information when it comes to the OSU studies, ISO stuff, types of casters that you need to help reduce ergonomic push-pull. It's all out there for free. Please go take a gander, check it out. We're always around for questions. Feel free to contact if you feel the need. We're always willing to help. But there's a tremendous amount of ergo information out there on the website for sure.
Yep, I agree. Thanks, Eric. And do push-pull testing. Follow the standards. Don't have it dictate everything that you're going to do.
It doesn't matter what gauge you use; they're all relatively close to the same.
They're all relatively close to the same. The human element, me doing the test and then Eric doing the same test, we could get, we could get similar results. We could get wildly different results. So there's a lot more to it. Take a bigger spectrum of information and get and try it in your environment with feedback from the people that are going to be pushing and pulling it all day. Because those are the folks that it matters to, and those are the folks that are going to be, affected by it, and those are the folks that are going to tell you the what is. They're gonna be like, we've been pushing these carts around for years, and we have 4 different types of casters on it, and these work in the long run, those don't work. You're going to get a lot more feedback from that perspective, and try stuff out. Not just in tests, not just in a vacuum, I guess is what I'm trying to say.
No, great advice. Thanks for the time today, Joe. I hope this was beneficial for everyone out there. Thanks for listening to the Industrial Lens, and we will see you next time.